Okay, this is question 3 from the Step 2 2024 paper. If you want to try this question out, this is the full question. But anyways, I'm gonna get into the solution right now. So the first thing I did when I read the first part was I basically drew a diagram to trying to try to visualize what is going on. And basically this question is all about a point on a circle, so this point P, and we're basically going to be transforming this point around. But the first part is unrelated to that. They just wanted to work out what the value of Q is, right? In terms of theta. So we aren't given that much information. I mean, there's not that much we can do. The only thing we can do is basically work out the equation of the line. So that's what I did. I worked out the equation of the line using this formula, or using the equation of a line in this form, basically. And let's see, yeah, so I used these, yeah, so I used these two pairs to work for y, y1 and x1. And for the gradient, I used this pair and this one, just because I thought that would make it as simple as possible. But when you do that, you should get something like this. And they have their q in the form of theta over 2, right? Whereas we have ours in just theta, so it's probably a good idea to turn our functions, write our functions in terms of theta over 2. So you can do that with the double angle formula, and when you do that, you get something like this. And then just doing a little bit of simplifying using the 1 minus sine squared equals cos squared on the bottom, and then you should get something like this, and then it will cancel out, and you'll get 10 of theta over 2. So yeah, that one's not bad. Basically 3 marks. And yeah, the next part basically says, on the next part basically gives us a new function, right? F1 of q is equal to 1 plus q over 1 minus q. And they want us to show that this function can be written in the form of this, right? So basically 10 and 10 with the addition of 2 angles. So it's probably a good idea to write the addition formula for 10. It looks something like this. And if we substitute our previous value of q that we worked out into this function, we get something like this, right? And so let's try and compare what we have right now to what we're trying to get. So if we expand out this half inside this function, you'll get tan of theta over 2 plus pi over 4. And we compare that to what we have. Well, you can sort of kind of match up the tan of theta over 2 to tan b, right? But that just leaves us with, well, what is the value of tan a? Well, the only value that tan a can be will be pi over 4, right? Because conveniently, we have pi over 4 here, and tan of pi over 4 equals 1. So yeah, that's our tan a basically. That should give us something like this, which is basically in this form. The only thing we need to do is factorize out the half, and then you get what they have. Part B tells us basically let Q1 be the point with F1 of Q, and P1 be a point of intersection with the line NQ1 and the circle. And they want us to geometrically describe the relationship between P and P1. Okay, well, let's see. Yeah, so basically what that was saying was we have a new point Q1, right? Which is somewhere on the y-axis. And the line N and Q1, basically, if you extend that line, it will touch it'll meet the circle somewhere, and that point is P1, and we basically want to find the relationship between P and P1. So the idea is we have a relationship between P and Q, right? That being theta. So in part B, we basically have a new value of Q with a new theta, which is theta plus pi over 2, which means that the new value of P, or the new point P, P1 basically, should be the same point as P, except the angle is just added by pi over 2, right? So geometrically, that's just the P1 being rotated, or P being rotated by pi over 2 radians anticlockwise. So yeah, that's the relationship between P and P1. The next parts are basically just the same thing, right? It's more transformations and more like describing the geometric relationship between P and new points. Part A is basically just the opposite of the previous part. In this part, we are given the transformation, right, or rotation in this case, and we want to find the value of Q, right? Well, in this part, the transformation or the rotation was pi over 2 radians, right? And this one is pi over 3, so we literally just plug in, or substitute pi over 3 instead of pi over 2. So f2 of Q should equal something like this. And then they want us to find it in terms of Q. So we just expand it out, right? So we get things in terms of theta over tan of theta over 2, because that's what Q is. And then when you basically expand it out using the addition formula, you get something like this, and then you can simplify it, right? I multiplied by root 3 over root 3, and then you get something like this. And that's in terms of Q, so that's fine. Then for part B, we're given a new function, f3 of Q, and then they want us to describe geometrically the relationship between P and P3. So it's basically the same as this, except the difference in the function is that the top and bottom, their signs are minus, right? For Q at least. So, well, the first thing we could say is that f3 of minus Q is equal to f1 of Q, or the other way around, either way. Which means that, did I write that down? Oh yeah, over here. Yeah, so I wrote f3 of Q is equal to f1 of minus Q, and some other just random information. Yeah, so if we're using this idea, then we can say, well, because it's just the same as f1, right? But then it's just minus Q. Well, minus Q is the same. Wait, what the heck did I just do? Yeah, so minus Q is just the same as saying that the angle is negative as well. So it's basically just the same as f1 of Q, except the angle is minus. Hopefully that made sense. Anyway, that just corresponds to, oh yeah, I had this whole explanation. So if we imagine that, okay, well, P is equal to the point cos theta and sine theta when we had Q as tan of theta over 2. That means that P3 has to be this, right? When Q3 is tan of tan of a half times pi over 2 minus theta, right? Because we just substitute the new value of theta into cos and sine. So you get something like this. But you can actually simplify this down to just sine and cos. And so what you notice is that you've basically just flipped sine and cos, or you flipped the x and y values, which is just the same as being reflected by the line y equals x. So that's the geometric relation between P and P3. The next part or the final part, is basically just a composition of all these transformations. So first you do f2 of q, then you do f3 of q, then you do the inverse of f2. So if you remember, f2 was just anti-clockwise rotation by pi over 3 radians. Then f3 is the reflection about the line y equals x. And then the inverse would just be the opposite, right? Because if you imagine if we applied the inverse here, that would just give us back q, right? So that would mean to go from p2 back to p, we would just need to go pi over 3 degrees clockwise instead. So that's the order of rotation, the order of the transformations basically. It's first rotate by pi over 3 anti-clockwise, then reflect by y equals x, and then finally rotate by pi over 3 clockwise. And that's the whole transformation between p and p4. Yeah, and that's the whole question actually. To be honest, not that bad. Anyway, yeah, goodbye.